So the topic of this video is going to be about how we're going to use the balanced chemical reaction to determine and utilize relationships between number quantities of one substance and another that are both in the same chemical reaction. So we're going to use an example. It's going to follow one of the slides in the lecture notes. For example, if we have some silver and some sulfur, okay, these are both solids. They react to give a ionic compound, silver sulfide, which is also a solid. Now there's several things that have to be true. One is that mass has to be conserved. That is to say, if I start with some silver and some sulfur, there'll be a certain mass of material that when I'm done, it's exactly the same mass. We cannot create or destroy matter. We can lose some, but we can't. It doesn't just disappear on us and it doesn't come out of nowhere. And so this is obviously not balanced. And so now it is balanced. And so not only is the matter balanced, but actually the number of particles is balanced. And so not a single silver atom disappears or comes into being. And so if there's two silvers over here, there's got to be two over here. There's one sulfur, there's got to be one sulfur. Now everything is balanced on a number basis. And so one of the things about the molar mass of a substance is that we can look in the periodic table and say, the molar mass of silver is 107.9 grams in a mole. Okay, but we have 2 moles, and so we have, for example, if we're just doing this in molar quantities, and if we're doing a stoichiometric reaction where there's 1 mole of sulfur, that would be 32.07 grams. That's what's in the periodic table for the atomic mass of sulfur. And then, of course, silver sulfide, its molar mass is going to be the sum of these two. 107.9 times 2 plus 32.07, and we get 247.87. Okay. Now this is also true on a number basis, and so 2 silver atoms would react with 1 sulfur atom to give 1 Ag2S, silver sulfide formula unit. Okay, since this is an ionic substance, we don't have molecules. Otherwise, we'd use the word molecule. But in ionic compounds, there are no discrete molecules, just a ratio of ions. So, of course, it's just saying there's a 2 to 1 ratio of the particular substances. Okay, and this would also go for any other ratio, which is 2, 1, and 1. It could be 200, 100, 100, and so on. Okay, so the problem we're going to work is going to be an example, and we're going to say how many moles of silver sulfide can be made from, let's see what we're going to make it from. We're going to make it from 7 moles of silver. Okay. All right, and so we're going to start with 7.0 moles of silver. The conversion factor is going to be a number ratio, 2 to 1. Okay, so 1 of these gives me 2 of these. So I need, in the denominator, the number quantity of silver, so many moles. Okay, now if this had been atoms, then we could say atoms. Okay, but in our example, we're using moles. So 2 moles of silver corresponds to 1 mole of silver sulfide. And that's all there is to it. Now this might be one you could do in your head, but for example, there might be some ratios. It's not like an integer or anything like that. So if it's 7 divided by 2, I didn't even need my calculator for that. All right, so that's how we convert the number quantity of one substance in reaction to another. We use the stoichiometric coefficients out in front of the formula.